Namaste. Welcome to the video lecture series on the chapter Periodic Property and its Variation. In this video, that is video number 6, we are going to discuss one more periodic property that is known as metallic character. But before going into that, let us see what are metals. What are metal? So an element is said to be metal. An element is said to be metal if it shows a tendency to lose. If it shows a tendency to lose one or more than one electron from its valence shell. So if an element shows a tendency to lose one or more than one electron from its valence shell and results in a formation of positively charged ion, which is commonly known as cation, is called as metal. So if an element shows a tendency to lose one or more than one electron from its valence shell and results in a formation of positively charged ion, that is known as metal. So let us see few examples of metal. Like I have sodium, atomic number 11, electronic configuration 281. So sodium shows a tendency to lose this one electron from its valence shell and gets converted into positively charged sodium ion and attains electronic configuration of nearest noble gas, that's neon. Second example, I have magnesium, atomic number 12, electronic configuration 282. So magnesium shows a tendency to lose this 2 electron and gets converted into Mg plus 2 ion, and attains the electronic configuration of nearest noble gas, that's neon. Then I have aluminium, atomic number 13, electronic configuration 283. So aluminium shows a tendency to lose this 3 electron from its valence shell and gets converted into Al plus 3 ion and attains electronic configuration of nearest noble gas, that's neon. So here I can see element shows a tendency to lose electron and gets converted into positively charged ion. That's what we call it as a metal. Now in general, with our discussion, we can predict metals will have 1, 2 or 3 electrons in the valence shell. Metals will have 1, 2 or 3 electrons in their valence shell. Now let us continue our discussion on the factors on which metallic character depends. So let us see the very first factor, that is atomic size. So if the size of an atom is larger, that means if the atomic size increases, now electrons will be loosely held. So tendency to lose electron will increase because they have been lost easily, because they experience a lesser force of attraction towards the nucleus. As a result, these electrons will be lost easily. Hence, tendency to lose electron will increase and metallic character will increase. So, if the size of an atom is larger, that will favor metallic character. Second parameter which we have, that is ionization potential. So if the ionization potential increases, the electrons will be tightly held. Now as the electrons are tightly held, so they cannot be lost easily. So the tendency to lose electron will decrease because electrons are tightly held. Due to this, the metallic character will decrease. Now let us see what are the trend of this metallic character in modern periodic table. So the very first we are going to discuss, that is down the group. That is from top to bottom. So what happens to the metallic character as I move from top to bottom? So for this, I will take an example of one of the common groups in modern periodic table, that is group 1, that is group 1A, or the first group, which is commonly known as alkali metal. So the element present in this particular group is your lithium, then I have sodium, I have potassium, rubidium, and cesium. So lithium, sodium, potassium, rubidium, cesium. Now here I am not considering hydrogen. In all our previous video we have considered hydrogen, but here I am discussing metallic character, and hydrogen is not typical alkali metal. That's why I am skipping out that hydrogen. So as usual we used to draw. So let me draw the nucleus first. So this is nucleus of lithium, this is nucleus of sodium, this is nucleus of potassium, nucleus of rubidium, and this nucleus of cesium. Then let me draw the shells. So lithium has got 2 shells, sodium has got 3 shells, potassium has got 4 shells, rubidium has got 5 shells, and cesium has got 6 shells. So 1, 2, 3, 4, 5, and this is 6th one. Now as these are the elements which are present in first A group, so they got 1 electron in the valence shell, which are represented with 1 dot in the last shell. Okay. Then let me draw the atomic radius. So this is the atomic radius I am drawing. Okay. Now as you can see here, as I move from top to bottom, the atomic size increases because electrons are added in new shell. Lithium has got 2 shells, sodium has got 3 shells. Every time the number of shells goes on increasing. As the number of shells goes on increasing, the last electron will be loosely held. So the ionization potential will decrease to remove that electron. So as a result of this, my tendency to lose electron will increase. So here lithium will be less metallic in a first A group because of smaller size, and cesium will be most metallic element in the first A group as well as in periodic table also, because cesium has got largest atomic radius in modern periodic table. So cesium is most metallic element, although francium is there, but francium is radioactive, so do not consider that. So cesium is the most metallic element which is present in modern periodic table because it has got a larger size. So if as the size of cesium is larger, will require very less energy to remove the electron, so those electrons will be lost quickly. As a result, metallic character will increase. So as I can see here, from top to bottom, the size of an atom increases, hence the ionization potential will decrease. As a result, metallic character will increase. Now let us see how the metallic character changes as I move from left to right. So left to right means across period of the periodic table, that is from left to right. So as usual, normally what we do, we take a third period of the periodic table. So in our all discussions we consider third period of the periodic table. So let me have third period. The element present in third period is your sodium, magnesium, aluminium, silicon, phosphorus, sulfur, and chlorine. Sodium, electronic configuration 281, this is 282, this is 283 aluminium, 284, 285, 286 and 287. Now here, as I can see from top to bottom, as I can see from left to right in the third period of the periodic table. So here my observation is this: as I move from left hand side to right hand side, the nuclear charge is increasing. As I move from left hand side to right hand side, nuclear charge is increasing. Now let me draw the nucleus of sodium. So I have this is as a nucleus of sodium, this as a nucleus of chlorine, and these are the number of shell. First shell, second shell, third shell. These are the shell. First shell, second shell, third shell. The number of electrons. Now sodium has got only 1 electron in the valence shell, whereas chlorine has got 7 electrons in the valence shell. Now, the size we can look into. Now here, as we can see, from left to right, the nuclear charge increasing, the number of shell remains same, that is 3 shell only. That is 3 shell. Here I am having, this is a 3 shell. Here also I am having 3 shells. So number of shell is not increasing, but the nuclear charge becomes dominant factor. As a result of this, the size of an atom decreases. As the size of an atom decreases, ionization potential will increase because electrons will be tightly held. So my tendency to lose electron will decrease. Hence metallic character will decrease. So sodium, which has been present here, will be more metallic because of a large atomic size, and chlorine will be less or least metallic because of smaller size. Thank you for watching.